Dream Chaser sits completed, ready to fly, but it's been trapped on Earth for over a decade. How is this even possible? This sleek spaceplane was supposed to revolutionize cargo missions with runway landings, but one disastrous decision is killing its future, partnering with Vulcan Centaur. While SpaceX launches weekly, Dream Chaser can't even get its first flight. The shocking truth? ULA is hemorrhaging money at $400 million per launch versus SpaceX's $62 million, and now faces a $2 to $3 billion fire sale. Let's dive right in. Back in 2011, when NASA retired the space shuttle, America faced a humiliating reality. We couldn't send our own astronauts to space anymore. Russian Soyuz capsules became our only lifeline, at $90 million per seat. But what if diplomatic relations soured? What if Russia decided to cut us off completely? NASA's answer was brilliant. Fund multiple private companies to build competing spacecraft. Never again would America depend on others for space access. SpaceX got a contract. Boeing got one too. But NASA wanted insurance against failure. They wanted a third option that could revolutionize how we return cargo from space. Enter Dream Chaser, Sierra Space's elegant spaceplane. Unlike capsules that splash violently into oceans, Dream Chaser would glide home like an airplane, landing softly on runways. Delicate experiments could survive the journey. Temperature-sensitive materials would stay pristine. It promised to bring back the grace of the space shuttle era, but smaller, cheaper, and truly reusable. Here's where Sierra Space made the decision that would haunt them for over a decade. They partnered with United Launch Alliance's brand new Vulcan Centaur rocket. Think about this for a moment. They bet their entire future on a rocket that existed only on paper. Why such a risky choice? ULA offered them something irresistible, a guaranteed spot on Vulcan's second-ever flight. It seemed perfect. ULA needed customers to prove their rocket worked, and Dream Chaser needed a ride to space. The partnership looked like destiny. Vulcan was supposed to debut in 2019, then 2020, then 2021. Each delay pushed Dream Chaser further into the darkness. Engine problems plagued development. Supply chains collapsed. Manufacturing complications multiplied. By 2023, Sierra Space had completed their first flight-ready Dream Chaser, nicknamed Tenacity, but their rocket was still trapped in development hell. The SpaceX domination nobody saw coming. While Dream Chaser gathered dust, something extraordinary was happening across the industry. SpaceX's Falcon 9 was launching almost every week, building an unprecedented track record of reliability. Over 200 successful missions and counting. The rocket that skeptics once dismissed as too ambitious had become the gold standard of spaceflight. But Sierra Space couldn't just switch rockets. They'd invested millions in Vulcan integration. They'd signed contracts. They'd built their entire mission architecture around ULA's promises. They were trapped. When Vulcan finally launched in January 2024, 5 years behind schedule, you'd think Dream Chaser's nightmare was over. But that's when the real betrayal began. ULA had bigger fish to fry than NASA's commercial cargo missions. The U.S. military needed Vulcan certified for national security launches, contracts worth billions of dollars. Suddenly, Dream Chaser became a low-priority afterthought. Sierra Space watched in horror as their launch slot got bumped for military payloads. National security takes precedence, ULA explained. Commercial missions for NASA? They could wait indefinitely. Then came the devastating blow that shattered any remaining hope. Vulcan's solid rocket boosters developed critical problems, grounding the entire fleet. Dream Chaser wasn't just delayed, it was stranded. But the Vulcan delays were just symptoms of a much deeper cancer eating ULA alive. While SpaceX charges $62 million per launch, ULA's rockets cost over $400 million, more than 6 times as expensive. Their Delta IV heavy missions were financial disasters, bleeding money with every flight. How does a company survive when competitors offer the same service for 85% less? They don't. Industry insiders began whispering about ULA's inevitable collapse. Major contractors fled to SpaceX. Even longtime military customers started questioning ULA's sky-high prices. The rumors became reality when news broke that ULA was for sale. Potential buyers were offering only $2 to $3 billion, a fraction of the company's former valuation. The rocket giant that once dominated American spaceflight was now a distressed asset looking for a buyer. This financial crisis directly threatened Dream Chaser. How do you plan missions with a launch provider that might not exist next year? How do you trust a company that's hemorrhaging money and losing customers? The obvious solution was staring everyone in the face. Switch to SpaceX. Falcon 9 launches constantly, it's proven reliable, and it costs a fraction of ULA's prices. Problem solved, right? Wrong. Dream Chaser has a massive physical problem. It literally doesn't fit inside Falcon 9's payload fairing. The spacecraft measures 5 meters wide, but Falcon 9's fairing is only 4.6 meters. It's like trying to squeeze a luxury car into a compact parking space. Even worse, Dream Chaser with its cargo module stretches 13.6 meters long, but Falcon 9's fairing maxes out at 13.1 meters. Half a meter might not sound like much, but in rocket engineering, it might as well be a mile. But wait, SpaceX has another rocket in their arsenal? Falcon Heavy. It's essentially 3 Falcon 9 boosters strapped together, creating a 27-engine monster that produces 5 million pounds of thrust. It's the most powerful operational rocket in the world today. Falcon Heavy costs around $97 million per launch, still dramatically cheaper than ULA's $400 million price tag. And here's the crucial difference. It has larger payload fairings that could potentially accommodate Dream Chaser's oversized dimensions. SpaceX has even built custom fairings for special clients before. They've extended Falcon Heavy's fairing to 13.1 meters and discussed pushing it even further for unique missions. The technology exists, the rocket is proven, the price is right. So why hasn't Sierra Space made the switch? Switching rockets isn't just a technical decision, it's admitting catastrophic failure. Sierra Space would have to confess that their partnership with ULA was a decade-long mistake. They'd face congressional hearings demanding explanations. Investors would file lawsuits, the media would have a field day. NASA would also have to explain why they funded a spacecraft that couldn't launch on its assigned rocket. Taxpayers would demand answers about wasted money and missed opportunities. Heads would roll, careers would end. The political cost of switching might be higher than the technical cost of staying trapped. Meanwhile, Dream Chaser's revolutionary capabilities are going to waste. The spacecraft's runway landing system could transform how we return sensitive cargo from space. Biological experiments that would be destroyed by ocean splashdown could survive gentle runway touchdowns. Manufacturing processes requiring precise temperature control could finally work in space. But innovation means nothing if you can't reach orbit. The most brilliant spacecraft in history is worthless if it never leaves the ground. Dream Chaser has become a $2 billion museum piece, a monument to the consequences of choosing the wrong partner. Let's put this disaster in perspective. Dream Chaser has been in development for over a decade. In that same time frame, SpaceX has launched hundreds of missions, carried dozens of astronauts, and revolutionized space access. They've deployed thousands of satellites, resupplied the space station repeatedly, and even sent civilians to orbit. Dream Chaser's scorecard? 0 flights, 0 cargo delivered, 0 scientific breakthroughs enabled? Just an expensive reminder that in the space industry, picking the wrong launch partner can destroy everything. This crisis extends far beyond one grounded spacecraft. NASA's strategy of maintaining multiple launch providers is crumbling. If Dream Chaser can't fly, America loses crucial redundancy in space access. What happens if SpaceX faces problems? We're back to depending on a single provider, the exact situation NASA spent billions trying to avoid. International partners are watching nervously. If American companies can't deliver on promises, why should other nations trust our space industry? China's space program is advancing rapidly while we're stuck debugging partnership problems that should never have existed. Behind closed doors, the finger-pointing is vicious. ULA blames manufacturing delays and supplier problems. Sierra Space blames ULA's shifting priorities and broken promises. NASA blames both companies for poor planning and unrealistic expectations. Industry insiders whisper about heated boardroom battles, contract disputes, and executive power plays. Some suggest Sierra Space knew about Vulcan's problems years ago, but stayed committed to avoid admitting their mistake. Others claim ULA deliberately misled partners about their timeline. The truth is probably uglier than anyone wants to admit. A perfect storm of corporate incompetence, political pressure, and financial desperation that trapped a revolutionary spacecraft in development hell. Every month, Dream Chaser sits grounded. The damage spreads. Other companies are reconsidering their own partnerships, wondering if they'll suffer the same fate. Venture capital is flowing away from risky space ventures towards safer SpaceX partnerships. The message is crystal clear. In the modern space industry, choosing the right launch partner isn't just important, it's everything. Pick wrong, and you could spend a decade watching competitors succeed while your revolutionary technology gathers dust. Dream Chasers' engineers pour their hearts into perfecting systems that may never see space. Scientists design experiments for a platform that can't reach orbit. Taxpayers fund a program that can't deliver results. So what happens next? Sierra Space faces an impossible choice: swallow their pride and switch to SpaceX, which means redesigning integration systems and essentially starting over, or wait for Vulcan to solve its problems, which could take years, if it happens at all. ULA's financial struggles suggest time is running out fast. Every failed negotiation, every missed deadline, every lost contract pushes them closer to bankruptcy. If ULA collapses, Dream Chaser doesn't just lose its launch partner, it loses a decade of integration work. But here's the question that could determine everything. Is Sierra Space brave enough to admit their mistake and make the switch that could save Dream Chaser? Or will corporate pride and political pressure keep this revolutionary spacecraft trapped in the graveyard of broken promises? The answer to that question will determine whether Dream Chaser becomes a symbol of American innovation triumph or the most expensive cautionary tale in spaceflight history. And with each passing day, the window for salvation grows smaller. Dream Chaser's decade-long grounding reveals a harsh truth. Innovation without execution is just expensive art. While SpaceX revolutionized space access by controlling their entire supply chain, Sierra Space learned that brilliant engineering means nothing when your partner fails. This isn't just about one spacecraft. It's about the future of American space dominance. Every day, Dream Chaser sits grounded. China advances closer to space supremacy. Every missed opportunity weakens NASA's redundancy strategy. But here's what makes this story fascinating. We're witnessing the space industry's evolution in real time. Traditional aerospace giants like ULA are struggling to survive, while nimble companies like SpaceX rewrite the rules completely. The question isn't whether Dream Chaser will eventually fly, it's whether the American space industry will learn from this costly lesson. Will future partnerships prioritize proven reliability over political convenience? What do you think? Should Sierra Space have switched to SpaceX years ago, or was staying loyal to ULA the right call? And more importantly, what does this mean for humanity's next giant leap into space? The answer might determine who controls the final frontier. How is this even possible? SpaceX just revealed their V3 fuel transfer tube that's literally the size of an entire Falcon 9 rocket. This thing is about to change everything. But wait, there's more. While SpaceX is building the future, NASA is falling apart. 2,100 senior employees are leaving. Budget cuts are slashing science funding in half. James Webb and Hubble telescopes are fighting for survival. How can SpaceX be soaring while NASA is crashing? What does this mean for the future of space exploration? Let's dive right in. Remember when everyone said SpaceX was crazy for trying to land rockets? Well, they just did it again. This V3 fuel transfer tube isn't just big, it's literally the size of an entire Falcon 9 rocket. But here's the kicker. It fits inside Super Heavy's belly like a perfectly engineered spine. Picture this massive structure getting hoisted vertical at Starbase, passing through Mega Bay 2's doors while engineers watched in disbelief. The tube is wrapped in reinforcement rings from top to bottom, making it look like some kind of metallic backbone designed to survive the apocalypse. But why does SpaceX need something this insane? The brutal truth is that Starship's previous flip maneuvers were basically controlled chaos. The old system relied on gravity and atmospheric drag, essentially hoping physics would cooperate. Flight 9 proved this approach was a ticking time bomb. Here's what was killing SpaceX's dreams: fuel delivery. When you're dealing with 33 Raptor engines that need to fire simultaneously, you can't afford even a microsecond of fuel starvation. Just one engine getting fuel late creates a catastrophic imbalance. Think about balancing 33 flaming torches while standing on a tightrope, except the torches are rocket engines and the tightrope is suspended in space. That's what SpaceX was dealing with every single flight. Elon Musk himself dropped the bombshell on social media. This tube has to be very buff because it faces extreme loads, and a single leak could be game over. Let that sink in. One tiny